What's going on, guys? My name is Amos and I'm back again with another video. So in this video, let's talk about monotone sequences. Now let's look at the definition. So let's give ourselves some sequence x sub n. So we say let x sub n be a sequence of real numbers. So we say that the sequence x sub n is going to be increasing if it satisfies the following inequalities. So what we basically see here is that we see that x1 here is our first term. Now our first term can even be x0, but here we start at x1. So we said our first term is x1, then our second term is x2, and then we have the other terms that follow. Now we see that the previous term is always going to be, if the previous term is always less than or equal to the next term, then if that is true for all values of n, now this has to be true for all values of n in the set of natural numbers, then our sequence is going to be increasing. Then decreasing is the other way around. So if you look at all the terms of our sequence, we see that the previous term is always going to be bigger than the next term. Now, if this is true for all values of n in the set of natural numbers, then our sequence is going to be decreasing. Now, a sequence is going to be monotone if it is either increasing or decreasing. Now, if we change the sign here, instead of using the less than or equal to sign, if we use the strictly less than sign, then here we're going to have a strictly monotone, a strictly increasing sequence. Then if we use a greater than, a strictly greater than, instead of using a greater than or equal to, then we're going to have a strictly decreasing sequence, right? So this is what a monotone sequence is. So a monotone sequence is a sequence that is either increasing or decreasing. Now let's look at some examples of monotone sequences. So examples of monotonically increasing sequences. So examples, let's look at some examples of increasing sequences. Now the first example that we are going to look at here is we'll take a very simple example. Now let's look at x sub n, which is given by the terms 1, 2, 3, and then maybe we continue. Okay, we continue like so. And then if these numbers keep on increasing, maybe 4, 5, 6, 7, 8, 9, if we keep on going, so this sequence is going to be an increasing sequence, right? This sequence is going to be an increasing sequence. Maybe to help you understand what is happening here is I'm just going to put n here, but then we can have an infinite sequence. Okay, so here n is coming from the set of natural numbers. So we see that this sequence is clearly an increasing sequence. Then example number 2 is the following sequence. So the sequence, maybe let's use maybe a different color and maybe a different name. So if we choose maybe y sub n, which is the sequence, a, and then a squared, and then a to the power 3, and then maybe we keep on going like so. So we have to be very careful here. A has to be strictly greater than 1, because if a is equal to 1, then we're going to have a stationary sequence because we're going to have 1s throughout. So this is also another monotonically increasing sequence. So this is an increasing sequence. Then let's look at examples of decreasing sequences. Examples of decreasing sequences. So let's look at examples of decreasing sequences. Now I'll give you guys a very simple example, similar to example number 2. We'll actually start with that particular example, similar to example number 2, or the sequence b squared, and then b to the power 3, and then if we keep on, maybe we have b to the power n here, and then we keep on going like so. And then if b is strictly between 0 and 1, well, then this is going to be a decreasing sequence. So you have to be very careful here. And then another example of a decreasing sequence is the sequence. Maybe here we have 1, and then 1 divided by 2, and then 1 divided by 3, and then maybe we have 1 divided by n here, and then maybe we keep on going like so. So this is an example. This is another example of a decreasing sequence. Now, whenever it comes to talking about monotone sequences, we always want to talk about the monotone convergence theorem. So very important theorem. So we see that for a non-decreasing and bounded above sequence of real numbers. So what we're saying here is a non-decreasing sequence is basically we are in the first situation here. We're in the first situation. we are in this first situation. So this sequence is non-decreasing. So we are basically in this first situation, but maybe we might change the sign here to a less than. All right. So we're in, to simplify things, we are just in this first situation here. So for this, for this type of sequence, we see that the limit is going to exist. The limit is going to exist, but then the limit is going to be the supremum. So another way of writing this is, so maybe just to eliminate some of the noise that is here, what we can say here is that the limit of a sequence that is monotonically increasing, okay, the limit of a sequence that is monotonically increasing, so here we've used a sub n, well, this is equivalent to this, so the limit of the sequence a sub n, so maybe here we can say, you know, a sub n, the limit of the sequence a sub n is going to be equal to the supremum, of, so here we have of the terms a sub n, so such that, you know, n is going to be a natural number. And then, oops, so maybe here we need to use the curly braces like so. And then same here, we are in the second situation, right? We're putting ourselves in the second situation. So we're basically in this situation. So let's just make reference to what we've written here. So we are basically in this second situation, right? For a non-increasing and bounded below sequence of real numbers, well, this is what we basically have. So to maybe come up with something that is similar to what we have here, what we are saying here is that this is equivalent to saying that the limit of the sequence a sub n, like so, in this particular case, if we are in this situation, second scenario, then it is going to be equal to the infimum of the sequence, you know, a sub n. Now a sub n here is this one, this a sub n here is a real number, and then when we put the curly braces here, we're talking about the sequence, and then this has to be true for all you know, natural numbers and for all natural numbers here. And so that is all about monotone sequences and the monotone convergence theorem. I'll see you guys in the next video where we'll be talking about other interesting things. We've covered a lot so far, and I hope to see you guys in the next video.